Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at an introduction to vectors and get a basic idea about how they work. So let's go ahead and get started. So you can see here in the upper left-hand corner we have an example of a vector. And a vector is basically a quantity drawn as a line segment. So again, if you look clearly here, you can see we have a line segment here going from 0, 0 up to 3, 3. All right, so it's a line segment. All right, and so that's one trait of a vector, if you will. And a vector has other characteristics to it as well. It has a initial point. So if I look in our graph here, our initial point here is going to be A, and then our terminal point is the other term. It's going to be the B here. And then this distance right here from the initial point to the terminal point is something we call a magnitude. So let me go ahead and write that off to the side. Magnitude, I believe is how you spell it. Magnitude. All right. And so the magnitude is the distance from the initial point to the terminal point. And you could probably think of all kinds of ways to actually calculate the magnitude, but we're going to discuss that later. So another thing about a vector is that it has a sense of direction. So it's a directed line segment. In other words, if you look at our example here, I'm just going to delete some of this stuff so you can see clearly. You can see that it starts at 0, 0 and it goes to 3, 3. In other words, our vector here is going in this direction like so, if you will. And that is not just a line, it's a line that has a direction. It's going from one place to the other. Now, in terms of notation, there's lots and lots of different ways that you can write vector notation, if you will. So one, if I want to do a U, but it'll be like a bold U, so I'm going to try to make this thicker here, if you will. Something like this. So this is like a bold U here, like that. Another one is where you have just a regular U like this, but then you might have the arrow on top that indicates a vector. Another one is when you have a PQ, or I guess in my example here, an AB. So then you have the line on top like that. These are all interchangeable, if you will, in case you're wondering, in terms of how it is. Sometimes you'll see something where it'll tell you you have an initial point at whatever coordinates, like say 0, 0, whatever, and you have a terminal point at let's just say AB. That's another form of notation. And then we have something called standard notation. Standard notation is simply where you kind of have like these open triangle, kind of like this, and then you have the A and the B inside like that, and then you close it out like that. This is called standard position. All right, and so in other words, when you use standard position, I'm going to change the color here, this is kind of important. Standard, you are assuming that the initial point is 0, 0, and whatever AB is, that's the terminal point. So for example, if I have a terminal point, let's say here 3, 5, I could draw it like this. And so the assumption is that the initial point is 0, 0. And so standard position is a very, very classical way of dealing with this. Now, of course, there is a way to calculate the standard position. So I'm just going to go ahead and show you how to do that. If you want to find the standard position, what you do is of course, this is when you have two different values for your initial point and your terminal point. And what I mean by finding the standard position is sometimes a vector will not have an initial point of 0, 0. And so you have to take the whatever initial point that the other line starts at and do some subtraction to try to find it out. Now this is all theoretical right now, so let me see if I can make this practical for you by first talking about the actual way to do this. So let's say I have a vector, of A, B. Again, we're still talking theoretically here. To find this, to put this in standard position, because assuming it's not in standard position, in other words, the vector AB does not have an initial point of 0, 0, you will do something like this. So you have x2 minus x1, comma, y2 minus y1, like so. Now, what's going on here is that the x2 is the terminal position, and then the x1 and the y1 is the initial position, of a vector that is not in standard position. If you find the difference for these, you are able to calculate the actual standard position, which is what we want here, which is going to be this A, comma B inside this open triangle. Now, let me see if I can show you an example of this. We have a vector here. Let's say I have a vector that has an initial position. So it has an initial position of, we're going to call it Q. And Q is going to be right here at 2, 3. That's the initial position. And we have a terminal position at R, let's see here, 6, 4. Now we want to find out, okay, what is this, put this in standard position in other words. So we follow what we know here. This is going to be my x1 and my y1 because that's the initial position, and this is going to be my x2 and my y2. So to make this as simple as possible, we're just going to call this vector u, if you will. Change the color here. So u, vector u is going to be, because this is a different position, it's going to follow this. 6 minus 2, that comes from here and here. And then we have comma, 4 minus 3, because that comes from here and here. Alright? And so then our final answer is going to be something along these lines. 6 minus 2 is 4. And 4 minus 3 is 1. And that's our answer. So let's go ahead and check that. So if you look closely here, you can see that our first one here, this line segment AB goes from 2, 3 to 6, 4. So this is our original segment, and down, or excuse me, our original vector. And so here, by subtracting off these different values here, we were able to get the standard position here, which is 4, 1. So it was 2, 3, 6, 4. We subtract, let's see here, 6 from 2, and we subtract 4 from 3, and we're able to get the standard position of 4, 1. These vectors, they have the same magnitude, the same angle, all those things are all the same, but now we're in standard position, which is a little bit easier to work with for more advanced calculations. So what I'm going to do now is that I'm going to review what we talked about today and then wrap up the video. So today, we have an introduction into vectors, and vectors are simply a quantity that is drawn as a line segment. In other words, it is a line segment with a sense of direction that you often commonly find in a graph. So all of them have an initial point and a terminal point, and that distance from those two is called the magnitude. And all this stuff can be calculated, using basic stuff from trigonometry. In terms of notation, there are several different ways that you can notate vectors. So you can have the bold-faced letters here, or you can have a single letter with the arrow on top of it, or 2 letters with the arrow on top of it, or you can have something that talks about initial point to terminal point, whatever. And there's also something called standard position. Standard position assumes that the initial point is 0, 0, and it only indicates the terminal point because the initial point is assumed. And it's often captured with these open triangles like this. Now here, there are often many times where a vector is not in standard position. And so if you take what the values related to the position of the vector, you can use that information to put it in standard position. And so it's x2, y2, x2 minus x1, y2 minus y1, and you're able to get standard position. And so here, I gave you an example here. We have points at 2, 3, and we have points at 6, 4. And when we do all the basic subtraction, we get the initial position of 4, 1. And then on this slide, I showed you a picture of it. So right here, we have the original vector right here. And then here, after we take let's see here, 2, 3, that's the initial position for letter A. And 6, 4 right here, that's the terminal position right here, letter B. We subtract this from this, and we're able to move it down to where it's right here at 4, 1. Right here. Now again, why is it 4, 1? Because remember, the initial point is now 0, 0, and we only put the terminal point when we're using standard position. So I hope this video was useful for you and that you were able to understand what we talked about. My name is Derek Thomas. I am the Director of Educational Research Techniques. Take care.